Hi, I'm Rob Brennan, and today we're going to talk about making home networks more flexible and easy to use. This demo is by the FAME Strategic Research Cluster, sponsored by Science Foundation Ireland. FAME is developing solutions for managing the complexity of networks. This demo is produced by the Home Networks Application Scenario team, which I lead within FAME. It highlights work from TCD, WIT, UCC, and UCD. Okay, let's get going. Home networks are a really hot topic at the moment. It seems like suddenly we've moved from having maybe one or two devices in the home, like a PC or a set-top box, to having rapidly changing home networks of laptops, mobiles, game consoles, media centers, and perhaps even fridges, all competing for bandwidth and cooperating to provide us with services. The next big thing will be sharing those services with your buddies. Who wouldn't want to check what's in the fridge before they visit? Or perhaps with your service providers to allow them to give you a richer experience. Or so that you can sell them back services that you've developed to get discounts on your bill. Sometimes things go wrong in this zoo, and it can be hard to figure out where the problem is, let alone how to fix it. As networks become more connected and dynamic, security becomes even harder to guarantee too. In FAME, we're working on solutions for all of these issues. Okay, let's look at the setup. In this demo, we consider two home networks, yours and your friend's network. You have a home movies folder on your media center, and you want to give your friend access to them, or perhaps to specific movies. But you don't want your friend downloading movies to interfere with your online gaming or home office applications. You also want to be sure that sharing these movies doesn't open up your home network to attacks by internet hackers, but you know nothing about home router configuration. While the service is running, you'd like to know about the video quality seen by your friend, and if your network's causing problems, you'd like to know about them. We enable all this with a set of components running at your home gateway, media center, or PC. These are a media system sharing service based on the UPnP and XMPP standards, a federal relationship manager to manage fine-grained secure sharing, a bandwidth manager that can reconfigure your network based on your instructions, a security agent that knows about security threats and countermeasures and can automatically configure your firewall, terminal and network monitoring agents, and an intelligent monitoring display that make use of expert knowledge to help explain network problems to you as they happen. It's important to say that media file sharing is not the only target application, and most of the technologies used are very generic. So for example, we also use our technology to allow your friend to securely share terminal monitoring information from his network so that we can see what's happening at both ends of a connection. Now, let's look at how we share things with the Federal Relationship Manager, or FRM, first. The Federal Relationship Manager is a software system that allows users to share local capabilities with remote third parties. In this scenario, the capabilities are media files and devices within the user's HAN. When new UPnP devices or new media files are added to the HAN, they're automatically registered with the FRM and become available for sharing. HAN users can create relationships with remote HANs, subject to approval of both parties, of course. Once a relationship has been created, capabilities can be shared securely between the HANs. The capability models are based upon RDF, Resource Description Framework, and are thus easily extensible to incorporate complex attributes of the resources being shared. The FRM provides a RESTful interface that allows other services within the HAN to query its current sharing configuration, which can be used to automate the translation of these high-level sharing policies into low-level network and security configurations in a variety of formats. One of the ways the FRM policies get translated into network configurations is through the Policy-Based Bandwidth Manager. The controller system translates user requirements for network traffic classification. The developed system has two major components, the policy refiner and the policy abstractor. The policy refiner uses a root ontology to generate network configurations by exploiting the relations between a meta-model in the ontology. The policy abstractor also uses the root ontology to infer useful information from the network level information, which is essentially a part of the root ontology. Net result is sharing a capability as a gold service gets translated into a refined router configuration. And here we can see policy refinement in action. There are initially no policies on the server. Traffic is flowing with no priority for any specific service. Now we apply an FRM gold service policy for a shared capability. As you can see, policies are now deployed and enforced. Hence, the TOS bits are set on the IP packets. Now let's look at the shared service itself. This is a system we've developed to allow hands to share UPnP devices or services. To enable seamless integration of applications in the local HAN with remote UPnP devices, remote devices are represented locally as virtual UPnP devices. Virtual devices implement the UPnP specification by tunneling incoming requests over a secure XMPP connection to the remote HAN hosting the live device. From a client application's point of view, the virtual UPnP device is a regular device in the local HAN, and their interaction with it follows the UPnP standard protocol. For example, the remote media server is discovered in the local HAN, and we can browse it and view media content that was shared with the local HAN. The client application shows devices and services that are shared by friends with the local HAN. Sharing is configured through the FRM, such that when a resource is discovered locally, the system checks with the FRM to see if access is allowed. As shown here, you can browse and play shared remote media just as easily as local files. Now let's talk about the security agent. A HAN access control agent is installed on the HAN router to provide an automated way to configure the HAN firewall for non-technical users. The HANAC agent will listen for and process network access control requests. If FRM sharing requests are authorized by the trust management system, the HANAC agent will then consult and reason over an LDL ontology for best practice firewall countermeasures against known threats. These countermeasures are then automatically translated into low-level IP tables access control rules. In our example, the correct IP tables access control rules for XMPP and media streaming traffic are automatically generated and then deployed onto the HAN gateway. Finally, let's look at our intelligent monitoring display. Unfortunately, most HAN users must monitor and manage their own networks without a lot of support or expertise. We want to make this easier, so we break this down into 3 tasks. First, we're working with our industry partner Ericsson to enhance low-level monitoring data into a common format suitable for semantic reasoning. Secondly, we look at ways to aggregate this monitoring data using encoded insights from domain experts who understand the data. This builds on ongoing work in TCD to capture these valuable expert insights in a reusable and cost-effective way in a semantic model. Then, the abstracted monitoring data is suitable for presentation to HAN users. We present this information in an appropriate, easy-to-understand visual manner. We have successfully demonstrated this approach with our colleagues in UCD to diagnose issues in HAN wireless networks based on monitoring data from their Wi-Fi agent. As shown in the screenshot, HAN users can now identify faults caused by interference, hardware faults, or range issues without having to interpret wireless measurement metrics themselves. Well, that wraps it up from FAME Scenario E. If you have any comments, questions, or suggestions, please contact me on rob.brennan@cs.tcd.ie.